Good morning, everybody. Welcome back to Coding on Swiboe, the next generation text editor. Top of the show business, top of the show business. So first, the bad news. Actually, yesterday's broadcast has been lost forever, lost to eternity. And the reason is that I'm a stupid idiot. Actually, instead of exporting to YouTube, I actually pressed the delete button. And so the video was not exported to YouTube. As you can imagine, it was actually deleted. So I will refer to this episode as the lost level or the lost episode. And only the people who were live there assembled will ever remember it. And it was a stream to be remembered. It was a stream to be remembered. Very sad indeed. Second thing. Yesterday, I merged the first pull request from somebody else. Ta-da! So we actually got a contribution by Michael Neumann. It's Michael, right? Yeah, Michael Neumann. And he actually updated to the latest master of Mio. So not a big change, but hey, we'll take what we can get. Thanks so much, Michael. And welcome, and you will always be remembered as the first contributor to Swiboe. And what else do we have? Oh, right. I have something nice for you. We have icons. Look at that. Look at those beautiful icons. Look at that. I really love them. They basically, they represent, like they have the S for Swiboe. So if you look in your doc, you will immediately see that you're using something that starts with an S. And it also has this switchboard alliteration to it, right? Basically, you have the cable down here, and then all those plugins that are waiting to get their chance to handle a request. I think it's really great. So which one of you, so question to you folks, which one do you like better, the round or the one with the beveled edges? I really have a hard time deciding. I probably like this one a little better. Well, I think that's all. So let's get right into it. What did we do yesterday? Oh, I remember. We actually, oh yes. So in our Python code, we actually create two clients. And each of them had one callback, and then we registered them with different priorities. And the first one that gets called, the callback 1, is actually not handling. And so the second one gets its chance, and we actually verified that this worked, and I think that worked, right? I also have to trigger it, of course. And I trigger it by pressing S on the terminal GUI. So for all the people who weren't there yesterday, just let me summarize again. Basically, two clients that connect, right? Each of them registers an RPC with the same name. One has a lower priority than the other one. And actually right now inside of Swiboe, the lower priority is get called first. Of course, that is like very counterintuitive, so we will change it eventually. But for now, that's how it is. So the client 1 gets called first, and here is the callback, and it actually returns that it's not handling this RPC. And so Swiboe will actually call through to the next client, which is this one, and this callback, and this one will actually say, oh, well, yeah, I handled it. And so you can see when I press S in the terminal GUI, that is what I bound this RPC call to. Then you can see that it happens as expected. Callback 1 gets called, it doesn't handle it, and then callback gets called, and we're done. Oh, and we added support for arguments here, right? So basically, if I can print that out here. So like so. So quitting that, restarting that. And you can say, see that we pass some arbitrary arguments. We set that up when we set up the key binding, and they are passed to our callbacks. So, and we ended yesterday with me saying that the way we actually designed this here is not really great, because if an RPC returns okay, it has the chance to actually return a value to the caller. And also, if it returns an error, then it should also provide additional information about this error. And that is not easily expressible, right? I mean, in Python you can return multiple values, but in C you can't. And since this is a callback that gets eventually like brought back to C, we have to come up with a way of actually doing that with a single argument. And we could actually, if we only were interested in a Python client, we could also say, well, we return a Python object here, and then we deal with the Python object somehow through the Python C API in Rust. But of course, that is super ugly, and it doesn't transfer to other languages. So we are not going to do that. Instead, we have to come up with a way of returning something like a tuple by doing nothing but C function calls. And the obvious solution to that is actually replacing our constants that we have here through something like this. Swiboe RPC, maybe like that. RPC okay. Actually, we have to namespace that. We already learned that the hard way. RPC okay, and that takes actually a string, which must be a valid JSON object, I would say. Something like that. And similarly down here, it will actually call something called Swiboe RPC not handled, right? And that doesn't take any arguments. And then we can get rid of these, and we only have those functions to call. Of course, we also have to define what those functions are or what they're doing. So up here we say Swiboe RPC okay, and the return type is actually a pointer to a RPC result, and a pointer to an RPC result is nothing but another void pointer, right? Yes, I did import that. So like that, and the argument types for this one is what is it? Just a regular C string. And very similarly for RPC not handled, except that this doesn't take any arguments at all. Right, and then we just have to implement those functions over here in the correct file, please. That is in C client source lib. Here we are. And they should look very simple, I think, right? Basically, we have a RPC okay. That's how I called it, right? Yes. And what will that actually return? It's not taking a client though, it is taking a something like a string, but a const one, a const C-char pointer, and then we actually convert that to a string. JSON string, and that will be C stored to string, C buffer, and this I think we can just pass through to our RPC result. Don't we have that already on something? Yeah, there it is. That is what we want. So basically we put this here and say this is what we return. This will actually give us a enum value, but of course we cannot really return an enum value. We have to return some sort of pointer, so we make a box around this enum value, like so. And of course a box can also not be returned, so we actually return a const pointer to an RPC result. That is correct, right? A pointer to a const RPC result, right? And here we say actually that is unsafe, but we mem transmute that, like we cast it brutally from a box into a raw pointer, and done. So this looks very similar to how we returned our client in Connect. So up here it is actually. So we create a box of our client, and then we mem transmute that one into a mutable pointer, and we return that. So that works. And while we're on that, we can immediately also do the not handled one, which will look very similar. But instead of a success, it actually returns not handled, right? And now we have to go down to our callback function. Actually, I wanted to do that yesterday already. Let's define a type. C callback, maybe something like this, and that is actually this type, right? Right now it is. And then I can say down here, this is a C callback, and I think I have that somewhere else. Yes, here, where we actually pass it in. And that's a C callback. Now we only have to change it in one place. Oh, fat fingers today. How does it look? What do you think? Our callback now is no longer returning an integer though, it is now returning a const pointer to a RPC result object. And let's need a semicolon here, and we're nearly done. Nearly done. And here though, instead of, like, we basically get a result object back. And here we are very brutally unsafe transmuting that again. So basically we get a result as a pointer here. If we call, oh, we need both. So basically we call this. We call our callback and we get back one of those results, and that is now a pointer to a object, and we want to transmute that again back into a box, right? Because actually we take ownership of that. Here it is created, and now we take ownership in Rust of that, and once we don't need it anymore, we delete it. This is what we do. And yeah, that seems right to me. And then here we match on the result, like so. And now we don't have those constants anymore here. Instead, we actually have the real RPC result enums. So we have RPC result enums not handled, in which case we can simply, yeah, that actually was so correct. So we just call through to context finish and say this RPC is finished and we didn't handle the result. We have a OK value too, and that actually contains some JSON string. Or actually that's not a JSON string, right? That is actually a JSON object or value. What's the correct terminus? I don't know. I don't know. I don't know. I don't know. And actually, looking at that, that's also just calling through, right? Yeah, I think think I'm just stupid. It's just simple like that, right? We don't actually have to do any matching at all. We just hand through the value because the creation function already makes sure that the value that we get here is a valid one. So all of this code goes away and we have replaced it, and that should be it. Please build and show me all those errors. Private type in exported type signature. Oh well. I'm not shy about my types. Unused variable JSON string. That is definitely not correct. And why is it not correct? Because of this, we want to use it here, like so. And that should be it. What was that? That's not what I wanted. Go away, go away. Unused variable still. Oh, not handled actually does not have any arguments, so it, wow, that would have been a bad crash. Thanks, Rust. Transmute called on types with different sizes. Oh, it doesn't know what to transmute it into. Of course, that is a box of an RPC result. And now it's no longer different sizes, please. Apparently it is. Why is it? Because of this one, we actually have to unpack that. Oh, Jesus. Really fat fingers today. Okay, that compiled. Now let's see if it runs, and it should like basically still behave the same, except that we now get a return value, which we don't see. We also get a segmentation fault, which we see very nicely. And why is that the case? Why is that the case? I don't know. Let's look at the code. The backtrace doesn't tell me anything. So we have Swiboe RPC OK, that is up here. It returns a pointer to an RPC result, which is correct. And Swiboe RPC not handled, which returns not handled. That is also correct. And actually the callback 1 worked, so the RPC not handled seemed to have worked. We cannot be too sure about that actually. We have to check. Basically, let's see if we are still alive here, if we're still alive here, here, and here. That is true. Actually, this is the result, and we hold on to it, and here we just return it. And running it. Killing. I have to kill the terminal GUI. If our RPCs do not return, our terminal GUI will hang forever, which is probably not how it is supposed to be, but that's the way it is. Okay, it died in line 80. Interesting. Really interesting. So basically, I know what's wrong. We never informed Python about the change to our callbacks, right? We say our RPC callback here, that is actually something that returns in CUIN16, which is of course no longer true because it returns a pointer to RPC result, which we need to then hoist up to here. And now it works. Right? Oh. Terminal GUI again. Yes, now it works. Great. Great. And though unfortunately I don't think we can actually test that because yeah, so we have in the config file, like basically in our Lua part of the code. So we have the client call thingy, but I remember that this was also very like only outlined, right? We basically only have, where is it? Where is the call function? Call is called Lua call, and it has to be here, right? So what do? We actually, oh, we just ignore the return value. How very nice of yours. We just return it. We just don't do anything with it. Well, I mean, I cannot really print it out, because if I print it out, I mess up my terminal GUI again, but oh well, let's print it out real quick. Just to make sure that it's actually doing something. But then we also, in our Python code, we actually also should return something useful. So instead of this one, let's create a new dictionary that has foo and maybe has bloop, and bloop is a list, 1, 2, 4, 8, and that should be it, something like this. And here, instead of passing a string, we actually would like to have something like a JSON dump string. I think that's how it is called. Is it? Import JSON. Dump S, right? And that takes a dictionary, and that should be fine. Okay, then let's run it and see if I didn't mess anything up. If I press S now here, then we see we actually get a return. So it is OK, which is the OK of the Rust result enum, and then OK is actually the OK of the RPC call. And here we actually get foo bloop 148. Yeah, that seems right. So that seems to be working. Everything is returning nicely. So I'm satisfied with that. The remaining question, though, is now what to do with the error, right? Because basically we now handle what we handle. Okay, we handle not handled, but we don't handle. We do not return any errors, and of course that is probably not acceptable. So let's see. Here we are. What kind of errors are we actually supporting? So basically, this is the error that we have to support, right? Down here, that's our RPC result object. We handle OK, we handle not handled. But there's also error. And error is defined here. And we have to somehow construct that. And the problem that I have here is the error kind. And the error kind right now is basically, it is an unknown RPC, IO error, invalid arguments, and that's all the RPC errors that we support right now. Of course, we can add arbitrary more. But my question is now, how can I actually make sure that we handle like all of them? So I don't know if that is clear, but for example, let's go back into our Python code here. I kept the error code over here. So basically, if we now say callback 1 is actually not returning RPC not handled, but it returns something like RPC error, right? And now what kind of error? Like, how do we tell Python which error it is? One simple solution would be that we say, well, we just support the string here and say, well, the returned error is an IO error, and then we also provide the details, which might be none, but in this case we could say, well, details is JSON dump something like this, or maybe reason, I don't know. out of disk space. Yeah, something like this. So that feels iffy for some reasons to me. So one of the main reasons is basically in the Rust code, in this function here, we have to switch on this string somehow. And there is really no guarantee that that this string. So if we add a new error message, so for example, if we go over here and then we add something like an misc error, right? Something like this. We have to remember that we also go into our Python client and into our C client and update the string representation and the switch that we have on the string to actually handle this case. The compiler will not help us with that because it doesn't know that we convert a string into one of those enum kinds, right? And that is something that I find rather iffy. Another alternative that we could do is we could do something like, well, we implement here a method on error kind and say, well, there is something like pop from string, something like this, that takes a description string and returns an error kind, something like this. That is slightly better because it is right next to the definition, right? We can actually check that basically if we now add a new one here, there will still not be any warnings here if we don't match the new case, but it is at least closer by. It is not like buried somewhere in the Python client. So that's maybe a little better. And it could get even better if we say we also implement a toString method, though we don't actually have any real reason for a toString method right now. But if we do that, then we can actually, then we will get a warning, right? If we don't handle all the cases in here, then the compiler will actually shout at us, and then basically if we add something new here, then we get a compile warning down here, and then hopefully the programmer realizes if there's a toString method, there might also be a fromString method right above it, and then also add the correct case here. But we cannot be sure, unfortunately. And I don't think there's any real way around it, right? There is no enums in Python, so we cannot provide those enums somehow into Python. And yeah, I'm not too happy with that design. Let's look up the C types again and asks them for enums, and it comes back empty. Right. So there doesn't seem to be a way to do it. So let's do it like that. I kind of like that the best. So we have unknown RPC, and I will actually return unknown RPC. This our RPC functions do not have to call, right? We never need to deal explicitly with unknown RPCs, because if our client doesn't know an RPC doesn't have a callback function for a specific RPC, then it will not be able to actually it cannot call anything, and it will immediately return this error. So these functions do not really need to deal with them, but nevertheless we wrap them here to be complete. IO is IO error, and then we have error kind invalid args, and that is invalid args, right? And miscs right now we don't actually need. And here we actually do it exactly the opposite way. Basically we match on the description, and then we say if it is like so. Vim macros, they always work until they don't. I hope Swiboe can do better one day. So, like that, right? That's of course functions. Okay, and then we can actually go with this one, right? We basically say the Swiboe RPC error is either a string. I wonder how I can actually say that this string can also be 0 or empty or something like this. Let's see. Let's see if we can make that happen. So we're going back to our C client library file. Basically, I now want to implement this RPC function error here. And that will work like this, RPC error. I also have to define what this actually does. Actually, it takes an RPC result, it creates an RPC result, that is correct. And it takes, what does it take actually? It always takes this the string as first argument that we actually convert to something. And then it takes an optional second argument. And I'm not sure how to express an optional argument in a C API. Basically what I want to say is that the second string can be 0, and if it is, or null, and if it is null, then that actually means that we don't have a reason, right? We just leave the reason value in our error empty. Okay, so this cbuff is cbuff reason, and this is cbuff error name. Error name is C string to string, and the reason is either if cbuff reason is null, I think that exists, then it is none. Otherwise, it is some C string to string. Basically, that's how it should work, I guess. I think so. Apparently, I'm missing a closing brace, and this is cbuff error name. And I think that probably was it already. So basically, we now need to construct a error object. And to construct an error object, seems like there's no convenient method to do that. So, okay, we just construct it explicitly. So basically, we say our error is then RPC error, and the kind is error kind from string. What I'm doing? Wrong function. Wrong function. Here. Error kind from string. And error kind from string. Error name. And that can actually never fail, right? Basically, up here we say if we hear, like if there's, yeah, maybe if there's anything else, then we basically say in panic and say is not a valid error kind name, something like this, right? Because that's a programming error. If the programmer gives us a description that we cannot map to an error kind, that is very clearly a programming error, and that should be punished. That should be punished by actually blowing up. Yes, I think that's about right. So where's the error? Here's the error. And here we basically say, so this is correct, and now we still need the details, and the details is actually just passed through. I called the reason up here, let's call it details everywhere. Details, details, details. And of course, that is not quite correct because details has to be a Serde value. So basically what we would like to have here is we want to pass that as a string. So we already have that somewhere, I think. I think it was basically saying something like, okay, so the JSON string object is this here. And then we say Serde JSON from string, JSON string. And here again we say we expect this to work. Otherwise we say Swiboe RPC error got a details argument details. Let's make it a little less verbose. Details not valid JSON. And that's it, I think. Let's compile and see where it shouts at us. Do we still have those alive messages? We don't need them anymore. What? It compiles? That seems unlikely. Too many changes. Too many changes. And it's not compiling. So the world is fine. So this brace closes here, this one closes here, and we didn't close this one. So that's correct. And actually we don't actually return a success, we actually return an error, and the error is R, and that's it. Use of undeclared type or module error kind, and that is where? That is here, and that is correct because it is called RPC error kind. And getting there. So from string actually takes a reference to a string, that is correct. And then expected core option found nothing, and that's my favorite error actually. Having a semicolon at the end of a statement of a block means that you will not return your value, you will actually consume it, and that's not what we want. Mismatch types expected. Aha, same problem here. From string error name. Yeah, like so. Okay, it compiled. And what should it do now? That is also interesting. Actually, I would like to output the error here again because I would like to see the error. Basically, what we expect now to happen is where's our test? Where's our test file? Here it is. Basically, the callback one, which gets called first, actually returns with an IO error that has a stupid reason or something like that. And so this function should never be called, right? And let's see if that actually happens. Okras, actually I implemented the GTK GUI first, but was really underwhelmed how badly it performed under macOS X. Just the recompilation took forever. No, not the recompilation, the redrawing took forever until it actually got started. And it was really hard to pass redraw events around. Also, it didn't behave properly in the sense of you had to click twice into the window before you could actually resize it on a Mac OS X. So I kind of gave up on the GTK GUI for now and concentrated on the terminal GUI. So the terminal GUI is actually working, though it has very limited features. So you cannot really edit a file, you can only look at a file and you can fuzzy find the file. But yeah, will come all with time. So what happens? If I now press S, I would like to see an error, please. And I do, but not the error that I was expecting. Actually, the error that I see is unknown RPC and there are no details. And that is true because our Python file is not running. And if the Python file is not running, that means that, of course, the RPCs are not registered, so we cannot call them. So now it should actually work, and the error is now, boom! We have an error, the kind is I/O, and the reason is that we are out of disk space. Perfect. So let's remove this verbose logging here again. And I think we're at a very, very good place to cut the stream now. So what do we have? We actually are able to return from Python everything that an RPC can return, but we cannot handle streaming RPCs yet. I didn't really want to implement that because I feel that it needs, I want to do it differently than it is implemented right now. I hope that I will be able to write down a request for comments over the weekends, so to explain more what I actually have in mind for the RPC system. But maybe it makes still sense to wrap what is currently there, just so that we have feature parity between the C ABI client and the Rust client. I'm not sure yet. But of course, what is also very important is calling RPCs from Python, right? We can call into Python, but we cannot actually call other RPCs out of Python. And that is, of course, the other way, which is the easier way, which is why I didn't do it at the beginning. Like I started out with the harder part of it, and calling RPCs should be simpler, and of course we have to do those too. So basically we have two more to-dos here. Handle streaming RPCs and to call other RPCs. Okay, and with that, I'll cut the stream. I switch around for 5 more minutes for questions, and I see there are already some questions. Oh yeah, of course, I want to present, I want to show off what the terminal GUI can do right now. Basically, there we go. So if I press Ctrl-T, which is right now hardwired into the GUI, it will actually call the fuzzy matching plugin. So let me show you the code for that real quick. So if you look at the terminal GUI Rust file, you can see that somewhere here there's actually here. So hardwired right now is Q for exiting, and Ctrl-T will actually start the completer widget, and the completer widget is defined in the same file. And what it does is it calls the list files RPC, which is a streaming RPC, and then basically it has also it's a on-key implementation that allows you to fuzzy search through files, and once you actually choose one, and whenever it gets redrawn, it actually updates the fuzzy thingies that it has here, and whenever it gets redrawn, and once you select the file, it will actually open it in an editor. And if I actually go a little bit, like let's for example go a little further up, and I here say Rust Swiboe term GUI target debug term GUI. I should probably build a release binary for that, because you can really see the difference between release and debug for that in performance. But now I basically right. It is looking for our for our config file, so I just copy the two Lua files here real quick. Now it starts up, and you can see when I press Ctrl T, there are like much more files that it actually finds, and you can also see how it's slowing down in release mode. That is really, really fluid. And then I can say, for example, if I'm interested in this file that we're editing here right now, I say, well, C client source. Should have built the release build. That doesn't work. Okay. So I swallow my words here. I go back and cargo build release. And here too, we actually want the server to be in release mode, and that will take a while. So I answer some more questions, and then once this is done, I'll show you again, hopefully a little faster. Yeah, so the GTK GUI is not compiling right now. That's actually true. I'm not sure what I should do about it, if I should just go ahead and delete it, because it will be a lot of changes. But it took me a while to figure out how to actually draw text. So I also don't really want to lose that. But then there's Git, so if you delete something, it is not really gone. Eventually you can bring it back. I'm not quite sure. If you want to look into getting the GTK GUI to build again, then I would suggest looking into the terminal GUI. That is the one that's under active development right now. Also, I do not agree that terminal UIs are the only options when using SSH. You can already deploy a Swiboe server on a remote client and then actually connect with a GUI from your local machine to the server through an SSH tunnel. I showed that off on stream, I think last Friday. And that means that you actually can have a nice GUI and edit over an SSH connection, though your files and your environment is on a remote server. And that's was one of the design goals for Swiboe. Princess Rika, I'm not a huge fan of Qt either. I believe that if you want to have a nice GUI, it has to be native. And I hope that we actually get a native Cocoa GUI, so something like we have for Macwin right now, and I also hope that that we will get a Windows GUI eventually. I believe also that making a GUI, I mean, it's always work, but I believe it will be very little work if everything is a plugin. Then you basically only have to build the UI elements around it and wire up that a key press is transferred into an RPC. Wow, compiling release modes, that takes forever. So our server's already done, but the terminal GUI is still compiling. Oh, nearly done. Getting there. Yeah, actually, about a non-native GUI project, I did a ton of GTK in my life, and I did a bunch of Qt2, and it is always not satisfying if you run it on another operating system. It always doesn't look really nice. And the only thing that is cross-platform and looks good is a web GUI, right? If you embed Chrome somehow and then you have a Chrome UI, I think that is a really good solution. Unfortunately, it proves to be really slow, and you're constantly broken by changes in the browser. So let's try that again. Now we actually don't use the debug, we use the release terminal GUI, and now we tried it again, and maybe it is now a little faster. Maybe it is, I'm not quite sure. If I now, yeah, it is faster, definitely. So basically I say I'm interested in C client lib.rs, and you can see that the file is now the first one, and I can open it, and then you can see that I have a cursor. Actually, I think we did that on stream too, oh no, we didn't do it on stream, but basically what you can see is the key presses I do now, they are not hard-coded into the terminal GUI, but they're actually set up in our config.lua here. So basically, if I press down, for example, this one, it will actually call this this RPC GUI buffer view move and what this does is it calls this function with these arguments, and these arguments is actually a cursor ID, which is right now every cursor currently has this ID, which is true. Every cursor currently has this ID. Since there's only one cursor, it will actually react. But once we support multiple cursors, we have to somehow get the current cursor ID into this function. And it says line, like the delta, move one line down, and don't change the column index. And that's working, but it's clunky. Actually, it is like buggy. I know about it. So if you, for example, if you go at the end of a line and now you press a bunch of times more to the right, you actually also have to press a bunch of times more to the left before your cursor starts moving again. And of course, that is not desired and is also not correct. Also, if you're on a longer line and you go one down, and the line before was longer, and now you have to press a bunch of times left again to get the cursor moving again. But that's also a feature that I call, that comes from outlining, because I'm interested in getting the design of Swiboe right. I'm not really, I don't care about those features and bugs in here, because I know they can be fixed no matter what the design. And I hope somebody actually expresses interest in fixing them, because that is work that can be easily sharded. While I get the design right, somebody can start actually getting those features in place and make them nice. But for now, it is all just to get a feeling how everything will fit together. Patsy has been working on 100,000 line non-native GUI project. Should I delete it all? Well, that depends, right? It doesn't really need to be beautiful to work there, but yeah, you should definitely consider if you should delete it all. I mean, if you ever have used GIMP, for example, under Mac OS X, that is a huge project, and it's written in a cross-platform GUI, and it's a terrible experience under Mac OS. It behaves different than all the other Mac OS applications, and it's always clunky to work with. Okay, I don't see any more questions right now. No more questions, no more questions. Okay, so as always, I stick around in the chat for a while longer, so if you have any more questions, you can just ask me directly in chat. Okay, thanks very much for watching, and I talk to you guys tomorrow.